Okay, we're going over properties of a rhombus, which we briefly just talked about. A rhombus is any shape that has 4 equal sides. Okay, assume that these are equal here. So all squares are considered a rhombus, but not all rhombus are squares because it doesn't say anything about an angles. Squares must have 90-degree angles in order to be considered a square with 4 equal sides. Okay, a rhombus can be on a slant, so our angles could be different for all we know. So in this question, it says verify that the quadrilateral with vertices blah 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 PQRS is a rhombus. So we've graphed it. It looks pretty good. Probably is not a square by looking at it, but again, it doesn't matter if it's a square. We're just trying to prove it's a rhombus, which means we need to find that all 4 sides are the same length. In order to use that, we're going to use our distance formula. So our distance formula, if you guys recall, good. So x2 subtract x1 squared plus or minus y2 minus y1 squared. Good. So here's our distance formula. We're going to quickly just set up each side. We'll name them one at a time. So PQ, that will be the first distance we're going to solve. We'll call this our x1, y1, x2, y2. I'm going to plug it in. I won't rewrite the distance formula because we now know it. We're just going to go from there. So we'll do this one in red. The distance of the very first one. So that means we need x2, which is 0. Subtract 3 squared plus y2, which is 1, subtract 3 squared. Try to do a couple steps in our head here. What is 0 minus 3? What's that squared? Not negative 9. Positive. 1 minus 3? Squared. So we add 4. What is 4 plus 9? 13. So the distance of side PQ is root 13. We can find the root and get a decimal, but unless another one, I would go on the assumption, because every distance formula is going to use the square root, we're probably going to be looking at all answers being root 13. But if you're not comfortable with that, go to decimals. Just try to go as far as possible, okay? That way we can tell if the numbers are different. Even if they're a little bit different, it won't work. Next one we'll do is PS. So x1, we'll call this S2 and Y2. Point S is x2, y2. So that's 3 and 3 and 6 and 1. So let's do that distance. The distance being 3 and 3 and 6 and 1. So I'm going to write them up here again. We're dealing with 3, 3, 6, 1. And this will be our second coordinate. And that will be our first. So x2 being 6, subtract x1, which is 3 squared, plus y2, which is 1, subtract 3 squared. Find square root. What is 6 minus 3? Squared. 1 minus 3? Negative 2 squared. 9 plus 4 under the square root. What's this distance? Root 13. That's 2 of them. You can still have 2 sides that are the same and the other 2 don't have to be. Okay? Okay, now, here's technically a trick. Once we've discovered 3 sides are the same, I'm trying to think. Oh no, it is possible to have a 4th side that's not. We could get a trapezoid. Okay, it only works for angles. Sorry, I should have thought that one out first. Let's do QR. So QR. Oh jeez. It's okay. It's fine. We'll call this x1 and y1. Okay? Hey, the color changed. Alright, x2, y2, x1, y1. So we're looking at 0, 1, 3, negative 1. So 0, 1, 3, negative 1 are our points. This will be our 1, this will be our 2. Okay? We got to find the distance of this one also. x2 is 0, x1 is 3, y2 is 1, subtract negative 1 squared. This will be negative 3 squared, which is 9. 1 subtract negative 1 is 2. 2 squared is 4. What are we looking at? Root 13. And finally, the last one we do need to prove is RS. What color haven't we used? Blue, I think, right?
Isn't it already like the same?
No, there is a possibility if the angles weren't all the same. We have to still prove this one. There is a possibility. I'll draw one out for you in a second. Okay? What did I say it was? RS. So we're looking at R and S. That's 3, negative 1, 6, and 1. So 3, negative 1, 6, 1. Those are commas. So distance of our very last one here. We'll call this coordinate 1, coordinate 2. So x2 is 6 minus 3 squared plus y2 is 1 minus negative 1 squared. Is this going to work, guys?
Yeah.
6 minus 3 is going to be 3 squared is 9. 1 minus negative 1 is 2. 2 squared is 4. Root 13. So they all worked. And for those of you who are kind of unsure when you thought, well, what about if 3? Once I've proven 3 work, why can't I just say that the fourth one works? Let's zoom in again here. Okay, I'm going to show you what I mean by that. Here's a line. Now, what I'm going to do to this line is I'm going to copy it. I'm going to paste it twice. So these are the exact same lengths. Oh, can I twist them? Okay. Should be able to twist it. Okay. And then now, if it was like this, these two would be parallel right now. Okay. But since this is the diagonal of this, we know it's going to be a little longer on this side. So if I were to make this a four-sided shape, are 3 of the sides equal right now? 1, 2, R3 are equal. Will this one be the same? No. Okay? So that's why we had to prove that all 4 of the sides were the same distance. Okay? We couldn't stop at 3.
So is there like a sub-third class